Good morning. This is the beginning of week 5. I can't believe it's the beginning of week 5, but it is the beginning of week 5 um, of the course. And I don't have a lot to say this week other than to talk a little bit about the module this week. The module this week is on the Laplace transform. I have assigned the entire chapter as a reading, but primarily for purposes of the what you need to know about the Laplace transform and what we will do for the exam this coming weekend is sections 1 and 2 primarily, as well as I have included some of my own notes, PDF of my notes on Laplace and my notes on inverse Laplace, and then a couple of the videos. I go over some of those notes on examples of Laplace and examples of inverse Laplace. And I highly recommend, if it's been a while since you've done Laplace transforms, that you look over the supplementary information because your book is geared really toward, even though this is engineering mathematics, it's geared toward a very theoretical perspective. And so I have talked about a few more practical things. Primarily, as far as the exam goes, we will look at the Laplace transform and the inverse transform and the use of that, both taking the transform, taking the inverse transform, utilizing the properties that are given in the tables for both, utilizing partial fraction expansion. I also have a section here, a video here, where I present a guide to using MATLAB for Laplace transforms, and that might be useful. It is sometimes a useful check. Sometimes it's more confusing than it's worth, because MATLAB is going to present you with answers in a really interesting format, particularly even when you do partial fraction expansion. It's not necessarily going to be in a usable format. So if I recommend it, as long as you don't have any trouble, going back and forth from the way MATLAB gives the answer to the way the answer actually comes out. Now, having said that, it is not acceptable on the exam to say by use of MATLAB : and give an answer. I'm asking you on the exam to actually tell me what properties of the transform you're using and how you got the answer, and to show your work. And I'm aware that sometimes taking Laplace transforms and inverse transforms when you can recognize a form or a property is really just 1 or 2 lines. But in that case, you would need to say, using the property of time shifting, or whatever it is, using the shifting property, whatever property it is you use, and then refer to that property and then show how that gave you the transform or the inverse transform. So anyway, there's lots of videos up. Because this is a holiday week and because your exam is coming up this weekend, the homework assignment is rather short. I think there are only 6 or 7 problems. I also don't love the problem selection that they give you in the textbook. So once again, I would refer you to the Laplace notes and the inverse Laplace notes, because there are some worked out problems, I believe, in that section as well. So hopefully that'll help you this week. I'm getting ready to take the content live. It's Monday morning at 11 a.m. This homework will be due on Tuesday of next week, because all homework I'm trying to have due Tuesday of the following week. However, let me remind you that you do have an exam that will go live this Sunday. So I highly recommend that you get the Laplace homework done before then, so that you can ask me any questions that you might have. Particularly recommend that you get that done by Thursday or Friday, so that you know if you have any questions. I will try to be, as I said, a little more available this weekend to check my email should you have any questions about the exam, and we'll let that exam be live for approximately 24 hours, maybe a little longer. I'll just have to kind of see how many questions I actually put on the exam and how long I think, what is my assessment of how long it'll take you to work the problem. So the exam will essentially have 2 parts. One part will be the solution of differential equations, which will be the majority of the exam, and then the other part will be Laplace transforms and the use of Laplace transforms to solve differential equations, which will be a short portion of the exam, but easier. So I'm going to give you, a little more some questions that should be easier questions on Laplace. Um, at this point, the way I plan on structuring the exam is just giving you a number of differential equations to solve. The key to the exam not taking the entire 24 hours is that you recognize the form. So, you know, look and maybe summarize somewhere in your notes what is Euler's equation, or mark it in the book. What does Euler's equation look like? What does the Bessel equation look like? What, is the equation of constant coefficients? And how to recognize those, because I think that will be key to being able to do the exam in an efficient manner. You will need to show all of your work on the exam, and I will create on Blackboard an area for you to upload your exam. Um, the exam will be probably a PDF file that will come available sometime on Sunday afternoon, and I'll update you later this week on exactly when that will be. Otherwise, I wish you a good week and a happy 4th of July, and encourage you to try to take the day off because, like I said, I gave you a lighter homework load this week, so hopefully that'll allow you to take a couple days off and spend time with friends or family, um, and unwind a little bit before the exam next week. So thanks again, and I'll post this video on the main Blackboard site. As you obviously, if you see the video, you found it, and Module 5 will go live here in a few minutes.